So we're going to jump over to R3. So we're doing R1, R2. R3 is like this section that never dies. In this class, we'll do part of it tonight, and then we'll come back to R3 again in October. We'll come back to R3, and then we'll come back to R3 again in November. So it's this section that just never dies. It's got a lot of stuff in it, so we just get parts of it at a time. The first part that we're going to get is about rules of exponents with polynomials. Polynomials is the name of the section, but we're really doing rules of exponents first, and then we're adding and subtracting some polynomials, real basic stuff. Exactly what we just finished with like terms, just we call them polynomials now. So rules of exponents. The first rule is the product rule. Product meaning what kind of operation is going on between the things with exponents. What's going on here? It's a to the m times a to the n. So a product is multiplication. So anytime you're multiplying things that have exponents with the same base, the base is the a. A is the base, the big number at the bottom. The m and the n are the exponents. Anytime you're multiplying things at the same base, you're going to add the exponents. So you just add them up. An example of that would be something like x cubed times x to the fifth would be x to the what? 8. 5 plus 3 is 8. So there's an example of using that rule. So the product rule is to add exponents. That's what the product rule tells us. Okay? The power rule. The power rule is when you have something with an exponent raised to a power. So we have maybe a to the m in parentheses with an exponent on the outside. That rule is that you multiply. So like if you had x to the third raised to the fourth power, the final answer would be x to the 3 times 4, which would be 12. Good. Right? So the power rule is to multiply. You know it's a power rule when you see parentheses. That's the way I always, kind of try to tie that together. Is that you know it's a power rule if you see some parentheses with that. An extension of the power rule is when you combine that power rule with a product. Maybe you've got a to the m and b to the n, and then some other exponent out here. Let's call it p. That power rule on this product, this right here doesn't have the same base. A and B are different bases. So you can't put these two together because the base is different. If the base is different, you can't put them together. So you've got a power rule here, though, because you got parentheses with an exponent outside. It works like distributive property. That it's p times m and p times n on that. So that it would be a to the mp times b to the np. Example of that might be like x cubed y squared to the 5th power. And to give you x to the 15th, y to the 10th. Edge that one right. And so distributive properties, what that works like. It works the same way if it's division on the inside. Like if you had a to the m over b to the n. The bases are different, so you can't combine the a to the m and the b to the n. But the power rule lets you multiply to both exponents. So this p would multiply the m and get a to the mp. On the bottom, that p also multiplies to the exponent down there, b to the np. Example of that might be something like x to the 5th over y to the 3rd squared. That'd be x to the 10th over y to the 6th. Some examples of those power rules out of that. And then the last rule that we'll talk about is quotient rule. rule, the quotient rule. If you're multiplying, what do you do? When you're multiplying, the product rule said you do what with the exponents? Add them. So the opposite of multiplying is division, which is a quotient. The opposite of adding would be subtract. So the quotient rule deals with the same base, a to the m over a to the n. You subtract those. So example might be x to the 5th over x squared gets us x to the 3rd. Something simple like that. And obviously we can combine some of this stuff in various problems, but they're not going to get overly complicated with this stuff right now. When we get to more diverse polynomial stuff later on in the course and in 110, they do a little bit more with it, but they're not doing just incredibly hard stuff with us right now. Okay. So let's look at a few examples of just practicing these exponent rules and using them in a context of simplifying a problem. So the instructions would say simplify, and you'd have something real, we'll start with something real simple like y to the 6th times y to the 5th. And that's obviously a product rule because it's multiplication and the bases are the same. So if it's multiplication, the bases are the same, we're going to do what with the exponents? Add them up, y to the 11th, and you're done. Real simple. Make it a little tougher. Put a number in front, a coefficient. What do you do with those numbers in front? Multiply them, because we're multiplying everything together, right? So 3 times 4 would be 12. X to the what? 8. Add them. So multiply the coefficients, add the exponents. And that's easily confused and can happen, but just pay attention to what you're doing. You'll be okay. 6x to the 5th. Sometimes they'll throw 3 or 4 of them together here. Maybe it's something like that. 6x to the 5th, 9x to the 3rd times 2x squared. Well, what's the coefficient going to be? The number in front. 6 times 9 is 54 times 2, 108. So we got 108 x to the 10. And again, multiplying those numbers, I'm not overly concerned about you being able to do that without a calculator. We're beyond that. At this point, we're trying to make sure we can get some algebra done. Don't let the numbers stop you from doing the algebra. What if we had a power rule like maybe we got 2 to the 3rd, x to the 4th, and then parentheses is what that's in, to the 2nd power. Yeah, 2 to the 6th, x to the 8th. Can we evaluate what 2 to the 6th power is? Yeah, we could work that out. It's not too large of a number that it couldn't work out. So 2 to the 6th power, let's see, 2 raised to the 6th. You could do it that way, 64. Or if you wanted to do, work it out there by hand, you could. X to the 8th. Most of the time, if that's not a large number, like 12 digits long, they're going to work it out. And you're going to see that number there. But the exponent rule sure makes it a lot easier to get that number. All right. Example E. X to the 5th, y squared to the 4th. Good job. X to the 20, y to the 8. Multiply, distributive property style. Real simple. 3 over n to the third, parentheses to the fourth. And 3 to the fourth power would be 3 times 3 times 3 times 3. I think about that as, oh, well, that's 9 times 9 is 81.
Last year, sometimes we would do something like that, and if we didn't take 3 to the 4 down to 81, it would mark it wrong.
What class was it?
It's actually Math
130.
130.
130. Yeah, depending on which course you're doing, there, what they're after. You'll kind of see as you're doing the Canvas stuff what some of the problems are after. Most of them for this, they're going to work out the number because they're not going to get too large for us. In this first little while here, they're going to do most of it with that. There's some things in 110 that doesn't, but like I said, you won't have to worry about that in here as much. 130 is definitely a different course. It's a little wild. All right, so let's put a negative number in there. Negative 2 m to the 6th over x squared y in parentheses. So let's get tough here. To the 5th power. M to the 30, x to the, good job. Notice that I wrote the negative 2 in parentheses still. That's important because if I'm going to evaluate that, if it were an even exponent, it'd be more important, but it's an odd exponent, so it really is going to give me a negative answer anyway. Negative 2 to the 5th power, 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. And then m to the 30, x to the 10, y to the 5th. The thing we're implying there is that if there's not an exponent written, it's an understood 1 there. Keep that in, because that can come up and you think, I would say exponent of a 0. Well, zero exponent has a whole different meaning than a 1 exponent. 0 exponent, which is actually our next thing, the 0 exponent anything to the 0 power is 1. How much was the Powerball last week? 760 something million. Yeah, it was like 768 million, 842,172 dollars. Maybe that's what it was. But you put it to the 0 power, it's still 1. Yeah, I didn't need it. Would have been nice. I'll probably be like 95 and win it and be too old to do anything with it. So that'd be my luck. Okay, so 0 exponent. I always have to do this. A glass of water. I like to draw. So I don't get to draw very much in here. So a glass of water to the 0 power. Still 1. Doesn't matter. Anything to the 0 power, it's going to be 1. Use that to simplify things. It's going to make things really nice and work out for you. Okay, so anything to the 0 power you see, put a 1. All right. Still in the same section. Let's go to actually doing some stuff with polynomials and working with them just a little bit. We're not going to get too crazy. We're not going to factor them or anything right now. We will get to that. But polynomials have a few things that we want to kind of hone in here on this section. The terms that they have are the parts that are added or subtracted. So when I say, how many terms does it have, that's how many pieces are added, subtracted all together. Okay, so that's how many terms. So there's the pieces that are separated by addition or subtraction. The coefficients, we'll talk about those as we go here. Spell it right. C-O-E-F-I-C-I-E-N-T. Coefficients. Coefficients, those are the numbers in front of variables. We'll talk about the leading coefficient sometimes with polynomials, and that's just the one that's in front of the highest degree term. Is the leading coefficient. So coefficients, numbers in front of variables. If there's no variable, it can't be called a coefficient. Okay, it's called a constant if it doesn't have a variable. So coefficients are only things that have variables. The degree. This is an important thing. It's one of the things that we'll talk about quite a bit as we go through the course. And every time we revisit polynomials in R3, degree comes up again. So it's important to catch it now so that when we get back to it in October and November, I'm not having to go back over what's degree, what's it even mean, that sort of thing. So catch on how to find degree now, and then we start putting some meaning with it more as we go through R3 again and again and again and again. So degree of a term. So degree of a term is where it starts. The degree of a term is the sum of the exponents on variables. If there's exponents on regular numbers, that doesn't matter. It's only the exponents that are on the variables. When we look at the degree of a term, we're looking for the sum of the exponents on the variables for that particular term. And then we can find from that the degree of a polynomial, which is what we're really after. It's the highest degree of a term. Okay, so we'll see that as we go through some examples here. I'll get us through there. Okay, so let's just start with some polynomials, and we want to state the degree of the polynomial. State the degree of the polynomial. I know no idea what letter I'm on. H, I guess. That's what we'll call it. We'll pick H. That's a good one to start on. It's a letter my son has a little trouble with in preschool, so we work on H a lot. So here we go. We got 2x to the second, 5xy to the third, minus 6x. Okay? So we want to state the degree of the polynomial. So this polynomial has how many terms? 3. There's 3 pieces that are added or subtracted together. So that means we need to find the degree of each of the 3 terms. So the first term, 2x squared, has only one variable on it. What's the exponent on that variable? 2. So the degree of that term is 2. Okay? And so I'm just abbreviate degree. The second term, 5xy to the third, has 2 variables. What's the exponent on the x? 1. It's understood that that's a 1. So the degree of that term is the sum of the variables' exponents. So what's the degree of that term? 4. 3 plus 1 is 4. What's the degree of the third term? 1. Which one's the highest? Yeah. 4 is the highest. So the degree of the polynomial is 4. You pick the highest degree of the degrees of each term. Now you just got to find the degree of each term and then pick the highest. Okay? Simplify. 4x cubed minus 5x squared, 6x to the 5th minus 7. Sometimes it's easy like this one because it only has one variable. What's the degree of the first term? The first term? 3. The second term? 2. The third term? What's the degree of the last term? 0. There's no variables, so there's no exponent on a variable, so it's a 0. So 3, 2, 5, and 0. The biggest one being 5, so the degree is 5. Take the biggest. Later on, when we start doing larger degree polynomials and solving, what that tells us is that degree of 5 tells us how many answers we should get if we were to solve that to find the x-intercepts, is what that tells us out of that. So it's not a lost cause to find the degree. It is very important when it comes to that sort of thing. J. Let's do another one. 2x to the 4th, y to the 3rd, minus 3x to the 5th, y plus x to the 6th, y squared. That was a little busy. What's the degree of the first term? Second term? Last one? 8. Degree of the polynomial? 8. Don't get much easier than this. That stuff right there. That's cake. That's the kind of things you want to see on the quiz, right? Everybody wants to see that easy stuff, and that's one of the things we're trying to do here. All right, next section or next part of this section is the naming of polynomials. And you have to be careful when you name a polynomial because they're going to live with it the rest of their life. So you don't want to name a boy polynomial Sue or anything like that. That's a joke, kids. Naming a polynomial is based on the number of terms. And we'll do an example. So we're going to make a little chart here because I like charts. Organization is a wonderful thing. Lack of it is not. So if it's got a certain number of terms, it has a certain name. If it has one term, it's called a monomial. M-O-N-O. M-I-L. M-I-A-L. Monomial. That prefix M-O-N-O, mono, one. An example of a monomial, 2x. That's a monomial. Happens to have the degree of 1. That doesn't matter. We're looking at naming the thing. It's a monomial because it's only one term. It doesn't have any addition or subtraction going on. That makes it a monomial. If it's got 2 terms, when you ride a 2-wheeled recreational vehicle, it's called a what? Bicycle, right? So instead of a bicycle, we're going to have a binomial, right? 2 terms. Example of that would be something simple like x squared minus 9. 2 terms separated by addition or subtraction. Real simple binomial. 3 terms, trinomial. X squared plus 7x plus 12 would be a good example of that. 3 terms separated by addition or subtraction. Trinomial. Anything bigger than that, we just call a polynomial. Here's a good example of a polynomial. Anything bigger than 3 terms. So we have special names for 1 term, 2 terms, and 3 terms. Anything 4 plus is called a polynomial. Technically, you could name them, with 4 terms, it'd be quadrinomial, but it doesn't roll off the tongue quite like monomial, binomial, and trinomial do. So we just call them polynomials if they're bigger than 4 or bigger. Okay, so that makes it really easy to do. So let's combine that with what we just did earlier with the simplifying an expression, combining like terms. So we want to simplify and name the polynomial. Letter K. Simplify and name the polynomial by the number of terms that the final answer has. So 2y to the 4th minus 3y squared plus y plus another polynomial, 4y to the fourth plus 7y squared minus 6y. So we got some addition happening here between two polynomials. So we want to put the like terms together. What goes with the 2y to the fourth? 4y to the fourth. And we're adding, so 2y to the fourth plus 4y to the fourth is 6y to the fourth. Then we have a negative 3y squared. Is there a like term for it? The plus 7y squared, so negative 3 plus 7 be positive 4y squared. When you're adding and subtracting, the exponents don't change. Be careful of that. That's a pretty common mistake, is when you're adding and subtracting to change the exponents. Don't change exponents when you're adding and subtracting. Last piece, you got the y and the negative 6y. Negative 5y. Yeah, minus 5y, negative 5y, same thing. We combined everything. We're good with simplifying. What do we call this polynomial? A trinomial. Cake, right? Easy stuff. Easy stuff. Let's do a tough one. Let's say we had 8 m to the fourth p to the fifth minus 9 m to the third p to the fifth plus 11 m to the fourth p to the third plus 15 m to the third p to the fifth plus 6 m squared p. This was a tough one. There's a lot going on. You got to be real careful about what's like terms. What are like terms in this scenario here?
8 m to the fourth and 1 m to the fourth, or 11 m to the fourth.
Do they have the same number of p's? No, so we can't put them together. So it's got to have the same variables and the same number of variables put together. So the 8 m to the fourth p to the fifth can't go with anything else. So I'll go to the next term.
Negative 23 p5 plus 15.
Yeah, those two guys can go together. So I'm just going to copy down the one that can't and then put the others together. So negative 9 and positive 15 would be plus 6m to the third, p to the fifth. And then the other two terms don't have anything to go with them, so we just bring them down. Plus 11 m to the fourth, p to the third, 6m to the second, p. How would we name this polynomial? It would be a polynomial. It doesn't have a name because it's got more than 3 terms. Or doesn't have a specific name. Polynomial. Okay. One more, and then we'll be on the last section of the night. 4 parentheses x squared minus 3x plus 7, close parentheses, minus 5 parentheses 2x squared minus 8x minus 4. What letter are we on here? M. Why I just don't do numbers instead of letters. Doing that way for 11 years, can't quit that. What should happen first? Okay. Can I combine anything in each individual parentheses? Nope, can't do that. Because that would imply I'm doing addition and subtraction first. What does the 4 out in front tell us? It's multiplying. In order of operations, that comes before the addition and subtraction. So we got to take care of that first. So what happens with the 4 and the stuff in parentheses right after it? Yeah, everybody in the parentheses gets multiplied by 4. So let's do that part. So it's like this. It's distributive property, 4x squared minus 12x plus 28 isn't this the same thing over here? Yeah, it's a -5, but it's still distributive property, right? So that's still multiplication happening before addition and subtraction. Order of operations still ruling the game. That's still the law we have to abide by. So it's a -5 times times 2, -10x squared, -5 times -8, positive 40x, negative times negative, positive 20. Now we don't have parentheses to worry about. We don't have any multiplication happening before addition and subtraction. We can combine like terms straightforward here. So 4x squared goes with the -10x squared. And then 12 and 40. How much? 28x. And then we got 28 and 20 be 48. And that would be called a trinomial. So that big, spell it right, it's trinomial. So combining like terms. Remember, if anytime you see parentheses with a number out in front or a letter out in front, multiply first and then combine like terms. You gotta follow that order of operations thing. Okay. All right. Last section of the night, we're going to finish up with something completely different than what we've been doing. Okay. So if you hang with me, we've got like 4 examples and we're done for the night. So I know you probably don't have graph paper with you. That's okay. You're not going to be completely ruined by that. It's okay. I'm going to use graph paper just so that my graphs look like they should. And so if you go back and watch the video, you'll see things happening in the right places. But section, we're skipping from the R chapter. We're going to jump over to section 2.1 and talk about rectangular coordinates. Coordinates. Rectangular coordinates. You might have heard this called the Cartesian plane. Maybe at some point. The XY plane is all it is, really. It's XY plane. So just draw yourself a grid here. You don't have to have the tick marks or anything on this first one here. We're just drawing a coordinate plane. Oops. I think I could draw a straight line with a ruler, but I can't. So we have a coordinate plane. The horizontal axis is which one? X. The vertical one is the y-axis. And there are things called quadrants because it divides the page into 4 pieces. Quadrants 4. It starts in the top right with quadrant 1, then goes counterclockwise 2, 3, 4, using Roman numerals to number those instead of digits, like normal digits. Because the ordered pairs inside use the normal digits. The quadrants use the Roman numerals. Is that how that works there? Ordered pairs, those are the rectangular coordinates. Ordered pairs. X first, Y second, always. Anytime, if you were doing a 3-dimensional graph, it's X, Y, then Z. It's always alphabetical order, the way that coordinates are placed with rectangular or non-rectangular coordinates. Polar coordinates are still that way. But ordered pairs, X and Y. And what we have here in the first quadrant, all the X values are positive. All the Y values are positive. In the second quadrant, what happens to the X values? X is negative, but Y is what? Still positive. In quadrant 3, double negative. In quadrant 4, positive X values, negative Y values. Okay? So just general knowledge about the coordinate plane is what we're after there. So that we could just take an ordered pair and decide where it's at on the coordinate plane by just knowing its signs without having to actually plot the point. We could tell you where it's at. So example there, where is 6, -3? Where's it located on the coordinate plane? In quadrant 4, because it's a positive x value with a negative y value. So that's quadrant 4. Quadrant 4 out of that. So just knowing that sort of stuff. We'll call that example A. Example B, where is 0, 7? Ooh, that's a tough one. Yeah, it's in between one. It's 0, 7 would be 0 in the x direction, 7 in the y direction. So it's up here. So it's between 1 and 2, but it's right on what? The y-axis. The y-axis is the dividing line. It's not really quadrant 1. It's not really quadrant 2. It's the dividing line. So that location for 0, 7 is actually the axis. It's on the y-axis. So if you're on an axis, you can't be in a quadrant because you're just teetering on the edge. Okay. All right. We are going to plot some points here. So I'm gonna draw a coordinate plane, and we're just gonna together plot some points based on what they are. So example C is plot the points. And so I'm going to put a list of points here. A is at 2, 5. B, -3, -5. C, 0, 3. D, 3, 0. E, -4, 2. And F at 0, 0. Okay. So I'm going to draw a coordinate plane here, and we'll plot them together here. Doesn't have to be real big. And if you got notebook paper, just kind of make tick marks that are close to uniform, in distance apart. Makes it, the grid just fine. I mean, I'm not overly picky about this. You'll have a grid on your lab. You'll have a grid on the quiz or the Canvas thing in the examining class. There'll be a grid there. So point A, 2, 5. How do I plot that point? So I start here at the origin, and I'm going to go to the right 2, to +2, and then go up 5 to +5. 1, 2, 3, 4, 5. And that's where I'm going to put my point. And I'm going to call that point A. What quadrant is point A in? 1. What quadrant would point B be located in? 3. So I'm going to go to -3, -5. That's point B. Where would point C be located? On the positive y-axis. 0, 3. There's point C. What about point D? The x-axis. At 3, 0. -4, 2. It's in quadrant 2. -4, 2. 0, 0. Yeah, it's right there. And it's special because it has its own name, origin. It's not on the y-axis or the x-axis. It's on both of them. It's the origin. It has its own name. Very important to know those things and be able to plot points, because this is the key to what we're doing next. Okay, is plotting those points. And if you can't plot points, you're going to have trouble with a lot of things that we're going to do, because we're going to have to graph several things throughout this course and 110. All right, so let's take that idea of plotting points and let's plot an equation using points. I know there are better ways sometimes to plot a linear equation, but I want to practice it with ordered pairs tonight. And that way, what I want you to see out of this is that no matter what the equation is, if you don't have a clue what the graph looks like, you can always pick ordered pairs, pick x values, get y values, and make a graph and make some sort of picture out of it. And a lot of times, a picture really does help you understand what's going on with the problem. So if you had an equation like this, y equals 4x minus 1. And let's pretend that none of us know what that looks like. Some of us may know that that's a straight line or a slanted line, and it doesn't have a curve to it. But we may know that. We may know that it has a y-intercept of -1. We may know it has a slope of 4. That's okay. Let's pretend we don't know that, and let's say, okay, I don't know anything about that equation, but I want to graph it. So I'm going to draw myself a coordinate plane, and I've got to find some way to graph that equation. And the way to graph that, or any equation, no matter what kind of equation it is, it can be really ugly equation or be really something pretty simple like this. The way to do that is make a table. Pick you some x values and work them out. And be smart about it. Don't pick hard x values. Definitely don't use fractions. Nobody wants to do that. Nobody wants to do fractions unless you got to. So pick some easy ones like -2, -1, 0, 1, and 2. That's going to get you a good picture of what's going on with that graph. And as we build through this course on learning some things about different kinds of equations, we're going to learn better ways to pick x values based on what kind of equation we've got. But those are some good generic ones to start off with. So with this one, I'm going to take -2 as x and plug it into the problem and work that out. 4 times -2 minus 1. Well, 4 times -2 is what? -8. -8 minus 1 be -9, right? So I get a y value. I'm going to do a different color. -9. Then I'm going to work out 4 times -1 minus 1. So that'd be -4 minus 1. It's -5. And then 4 times 0 minus 1. That's -1. And then 4 times 1 minus 1. 4 minus 1 is 3. 4 times 2 minus 1. Be 8 minus 1, which is 7. I've got 5 ordered pairs there. Now, 5 points that I can draw on the graph. I can just go to my coordinate plane and put those points there. So I would go to -2, -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And put a dot right there. So -2, -9. Then I would go to -1. So left 1, down 5. 1, 2, 3, 4, 5. 0, -1. It's right there on the y-axis at -1. 1, 3. Go to 1 and then go up 3. 1, 2, 3. 2, 7. 2, 1, 2, 3, 4, 5, 6, 7. I've got those 5 dots plotted. Is it pretty clear that that makes a straight line? We get a good picture of what this graph looks like, what the equation looks like on a graph by getting those 5 ordered pairs. And we get this straight line going on there. We get a good picture of what's happening by just picking some x values and working them out. Straight line, that's nice. What if it's not straight? Let's do one more and we're out of here. What if we had y equals, I think I told you 4 examples. I lied to you. I'm sorry, it's 5. Y equals x squared minus 4. Now, some of us may know what that looks like. Just remember, we remember something from algebra in high school. And we know what that looks like. It doesn't matter if we do or not. We can still get the picture of the graph by just picking some x values and finding the y values that go with it. I'm going to stick to my guns, and I'm going to go with those 5 generic ones because I don't really know much about this. I'm going to pick -2, -1, 0, 1, and 2, and plug those in and get the y value that goes with it. and see if I can get just a general idea what this picture looks like. So if I plug in -2, and I apply the things that we've done already, order of operations says exponent happens first. So -2 squared is 4. 4 minus 4 is 0. Okay? And then plug in a -1. Order of operations still happening. 1 minus 4 would be -3. Right? And then 0 plugged in. That's an easier one. I like that one. It'd be -4. And then 1 plugged in. That's pretty easy. I can do that. That's -3 again. And 2 plugged in is back to 0 again. That's a weird looking table. Doesn't matter. I got some values. I know some ordered pairs that I can draw a graph with. And that's the key. That's what we're after here, is taking these ordered pairs and building a picture just by picking some x values and finding the y values that go with them. Okay? So I'm going to plot those points. -2, 0. -1, -3. 0, -4. 1, -3. And then 2, 0. Okay? It kind of has a little bit of a V type shape to it, but it's not as steep between here and here as it is there. So it's not quite just a straight V. It's more of kind of a looping shape. Does anybody ever remember seeing graphs like that in high school math or any other math class? It's a parabola is what the shape is, what it's called. It's a quadratic equation. But we get this picture of it just by picking some x values and working it out. If we had picked some more x values, we get an even better picture of it, or more details going on. As we progress through the course, we'll learn some things about quadratics and certain places that you want to pick different x values depending on the problem that you're given. But overall, the first night, it hasn't been too bad. I'm going to write the suggestions of problems that you can look at in your textbook. If you've got a different edition, the page number may be off by a little bit, but the problems should be about the same. Just go to that section, R1. You know, I'm putting like a bunch of problems up here. Y'all keep in mind, I'm not taking these up, and I'm not expecting you to do all 93 of them there on that first page. I'd say pick a few from each little subset and do some of those and check them with, you know, I'm saying do the odds because the odds are in the back of your textbook. You can check your answers. Make sure you're doing them right. And that way you're not just going into the Canvas thing blind. R2, page 17, R3, page 28, 1 through 43, odd. And then then 2.1, which is what we just did, page 178, 1 through 59, odd. The first Canvas quiz is not out there yet. It will be out there either tonight before you go to bed or tomorrow before you go to bed. So I haven't got that uploaded yet. I'll get that uploaded, and you'll have you've got 2 weeks to do it, so don't get in a rush to get it done tomorrow or anything like that. But I know some of you have got work schedules and different classes and things, so you don't want to get swamped here the first couple of weeks of classes. So we do not meet next week. We will meet again the following week, which is be September the 11th, I believe, is right. Yes, September the 11th we'll meet. We got labs at the beginning, and then lecture right after that, and then we would have our first exam on September the 18th. I look forward to getting to know you guys. I know we only meet once a week, so if I don't remember your name, don't hate me. I'm not that good. But I look forward to it. Guys, email me if you got questions, okay?
Have a good one.
All right, you too.